I am Arun Jain. I have done my BTech Honours from IIT Kharagpur. Now in this set of videos, we are going to learn about dipoles in small sections so that you don't get bored, right? Otherwise, a video lecture is always boring. So we'll try to keep sessions very small. The first lesson is an introduction to dipoles. What are dipoles? A dipole consists of two equal and opposite charges separated by a distance. So this is minus q charge plus q charge, and if they're separated by a distance d, we call it a dipole. Now for mathematical convenience, we call this distance 2a also. There are certain advantages for that. As we continue with this discussion, we learn that 2a, calling it 2a is useful. So dipole consists of two equal and opposite charges separated by a distance. An atom or molecule can become a dipole in the presence of an external electric field. So if a spherical atom is here, then we put it in an electric field, an external electric field. So the electric field is in this direction. Because the electric field is in this direction, minus charge, the electrons, will try to move opposite to the electric field. So this atom will become spherical, and therefore here we'll have minus charges and here plus charges. So this atom will become a dipole. Suppose we want to make a dipole here in the class. How can we do that? We need a charge rod, either plus or minus, anything is okay. We need two spherical conductors on insulating stands, and these spherical conductors are in contact here. Now because of these charge rods, the minus charge will come this side, the electrons, the plus charge will stay behind here, and now keeping this rod in place, we'll separate out the two spherical conductors. So this minus charge will remain on this sphere and this plus charge will be here. Both the charges will be equally distributed, uniformly distributed on the outer surface, and now we have got a dipole, equal and opposite charge separated by a distance. A dipole has a very important property called dipole moment, P vector. This dipole moment is a vector and is directed from minus charge to plus charge. All the other properties that we'll be discussing are directed from plus to minus. But this dipole moment is one thing that is directed from minus to plus charge. Very important to remember. When you study magnetism, we realize that magnetic dipole moment is also directed from south pole to north pole. Then everything will be from north pole to south pole. But dipole moment is one thing that is directed from minus charge to plus charge. And the magnitude of this dipole moment is equal to the product of the magnitude of either charges, both charges are same magnitude, multiplied by the distance between them. So therefore this dipole moment P will be Q into D. And if you call D as 2A, this will become Q into 2A. There's a reason why we call it 2A. Okay, remember that. And remember also that this distance is not double the distance. This is the distance between the two charges. Only thing we are calling it 2A. So Q into 2A is dipole moment and is directed from minus charge to plus charge. Now if you look at a dipole has got minus charge, plus charge, and the dipole moment is from minus charge to plus charge. So dipole moment will be in this direction. Now if we extend this line connecting the two charges, we call that line axial line. Either way, okay, this is called axial line, and any point on this line is called axial point. So this is axial point. This point location, sometimes we call it end-on position. That is same as an axial point. So any point on the line joining the charges is called axial point. And if you draw a perpendicular to this line passing to the center of the dipole, this we call it equatorial point. Equatorial line, and any point on this line is called equatorial point. Now sometimes we call this as broadside on position. That was end on position. This is broadside on position. A different name for that. So the line joining the two charges, if you extend it, we get the axial line, and any point on that line is called axial point. And if you draw a perpendicular to the midpoint, the center of the dipole, okay, that is equatorial line, and any point on that will be called equatorial point. So these are the basics of dipoles. A dipole consists of two equal and opposite charges separated by a distance. Dipole has got a very important property called dipole moment. P vector is directed from minus charge to plus charge. If we join the two charges and extend that line, we get the axial line. Any point on that line is called axial point, and a line perpendicular to this line passing through midpoint of dipole is called equatorial line, and any point on the equatorial line is called equatorial point. Axial point basically is at the end on position, and equatorial point is on the broadside on position. In the next lesson, we are going to learn how to calculate electric field at an axial point.